Okay, hello everyone. Welcome to week 6 lab session. And in this session, I want us to do the lab project we're working on. And also we're going to target 2 additional window functions under the value category. So these are basically positional window functions. This is what I'm referring to right here. These are positional window functions. Right, you're going to see this a lot in businesses. They're going to ask you to compare the current year sales to last year's sales, or compare current quota sales to last quota sales, stuff like that. That's going backwards, that's previous. You can also go next. So lack means you're going backwards. This will give you a previous value. This is very important. So with lack, you're going backwards. You always need to know the position. So current to previous, that's a comparison. That's why we call this positional window functions. So the lack function fetches a value from the past. Previous, compare previous sales with current month sales. Meanwhile, the lead does the opposite. It goes forward. So the lead function, you're looking at the next. Compare current sales maybe with tomorrow's sales. Is the next. Right. So there's this previous and next. This is very, very important business questions you likely encounter. And that's where I want us to begin. Right. And I found this very interesting article. I have provided also the databases we're going to use. Let me just go to the file we received today. Just a moment. Let me clear up this drawing. So on the files we received today, let's begin with this window function. Oh, sorry. Let me go to the lab and window function lab database. Where is that script? This one right here. Remember, we have a window function database. So this one I've added the underscore lab so that it's different. Right. So we already have a window function database. We're going to open this one and execute. It's going to create window function underscore lab. Right. So that's what we're going to do. Can you just go ahead? Let's open that script and execute the database so that we have the database we're going to use for today. So lab, and then window function lab. Click on execute. The tutorial we're going to be using to have a deeper dive into this positional window function is going to be this. Let me share the link. But first, go ahead and click on execute. Once you have that script open, let's create that database. So this is going to create a window function underscore lab database. So once the script is executed, just go ahead and shut it down so that you don't run it by mistake. Just shut it down. Right. And then if you go now to your Object Explorer window, you can refresh on the database and you're going to see a new database called window function underscore lab. And that's what we're going to use to demonstrate this very important set of functions, the lack and the lead. Right. So the lecture is going to be based on this link you see right here. So the lack and lead function. I'm just going to copy this again. I'm going to build the lecture material as we proceed. So I'm just going to put it right here. That's the article we're going to be exploring today. And this is talking about the lack and lead functions in SQL. Right. So that's the main article we're going to use. Right. So this is it right here. I'm just going to put this title. Right. Okay. Let's get started on this. So lack and lead are positional functions. This is very important. Right. So positional in the sense that we can use this function to compare current sales to maybe last year's sales. Right. So positional in the sense that you're looking at current sales as today's sales or this year's sales, and you want to compare with last year's sales, in that case, you're going to use the lag function. If you want to see how the sales in 20, sales in 2021, for example, compare with sales in, we're currently in 2024, sales in 2023 compare with sales in 2024, that comparison, you can go backwards. You're going to use the lag function. Right. I want to just take you to the syntax without wasting any time. This is the syntax right here. It has 3 parameters, right? But out of these 3 parameters, only one is mandatory. The other ones are just optional. So on the syntax, you're going to look at this. There are 3 parts of the lag function. First is the expression or the column you're doing the investigation on. And then we have this. This is something you have to understand. Each time you see a square bracket around the parameters of a function, it means optional. You see, there are no square brackets on this one. This is mandatory. This is a universal way of presenting parameters or arguments of a function. If you see square brackets around the parameter or arguments of a function, you're dealing with an optional function, an optional parameter, or an optional argument. This is very important. So the lag function can take 3 parameters, 1, 2, 3. Of these 3, 2 are optional. You see these 2 are enclosed. Let me show you the enclosure right here. They're enclosed in the square bracket. It indicates that these 2 parameters are optional. Right. As we proceed, I'm going to explain what this does, the offset and the default value. Right. And of course, since this is a window function, it uses what the over clause. And then since these are positional functions, sorting is very important. We saw that sorting was mandatory for these functions, the ranking functions. All these functions requires order by. If you are ranking using the row number function, you don't put order by in the over clause, you're going to get an error. Same with the rank, same with the dense rank. So same thing with the value function. These are positional. So ordering is very important, right? So if you look at the syntax right here, the over clause is present because it's a window function. You have to understand that over clause plays a very crucial role in window functions. It defines the window. Your window is defined using the over clause, which accommodates 2 parameters or 2 expressions, partition by and order by. So for ranking and positional functions, they all make use of the order by. See? All right, let me just take you to the next so that these things begin to make sense. Right now, we're still at the surface. I'm going to skip this. So we have this table. We have this from the window function lab database we just executed. We have the sale table. If you just go ahead and connect to window function lab, and we can begin this process, use window function lab right here. And then let's just explore what that sale table looks like. So I'm just going to do a select star from sale, or you can just put dbo.sale, dbo.sale right here. So this is what we have. This is the same thing we have in this article right here. So in a positional framework, if I'm on this row, what sale value came before this? That's what the lag function will do. Since there's no sale value before this row, the lag function will return 0 or null. If I'm on this sale, what sale value came before this one? Is this one. So the lag function will go 1 row backwards and fetch this value so that we can compare this and this on the same row. If I'm on this row, what sale value came before this one? Is this one. So I can compare this and this on the same row. So the lag function goes one step backwards and pulls this. So you see that sorting is very important. Once you sort in the desired order, that's exactly what the function will do. So this is it right here. This is the code to do that. So give me, let me just read the description. As with the window function, lag requires the over clause. Can take optional parameters. We're going to talk about those two later on, which will be explained later. So with lag, you must specify an order by. So you first of all have to sort. Right, since we're talking about sale value, you see that we order by sale value. And since the default was unspecified, this is ascending. So smallest, next smallest, largest. So sort by that. And then now what does the lag function do? It is assessing on the value. See, that is the expression or the column we are targeting. So if we pass the lag function on that column, it's the sale value, right? On any given row, it will go one step backwards based on your sorting and fetch the previous one. This is very, very important. Let's build this gradually. Let's build this together. Right. I want to show you this. And before I even demonstrate that, let me take you to this picture right here. It helps you. It helps a lot to explain what we're trying to do. We've sorted sale value in ascending order. We have this, this, and this. With this column right here is going backwards to pull the sale value, the previous sale value. And when you're using the lag function, this explains exactly what the lag function is doing. So you have to always know your current position. If this is our current position, this row, our current sale value is this. What was the previous? Based on this data set, we don't know. That's why the lag function returns null at the very beginning of the evaluation. We don't know the previous. Given this value, we don't know the previous. So the lag function is returning null. See that? Now, if you go now to the second row, given this value on the second row, what is the previous value? The lag function goes one step backwards and pull this. That's why you see this place right here. This column right here is the outcome of the lag function. See that? The first one, we don't know the previous. The lag function returns null. In the second row, we know the previous is this one. So the lag function fetches that and puts it right here. So we can compare this value, that's the current, to this, that's the previous on the same row. So you have to understand what the lag function is doing. It's going one step behind to pull previous values based on the analysis you're doing. You have to always respect the position. That's why we're using the order by. It's mandatory. You have to first of all sort and have that desired structure. And then on every given row, we ask ourselves what was the previous value. On this particular row, there was no previous value. The lag function returns null. If you go to the next row, this row, what was the previous sale value? Is this one. The lag function goes backward and returns that value. You see, that's how you can compare the sales for 2024, which is the current year, to the sales for 2023, which was the previous year. So it goes backwards and pull that value and brings it forward, and then we can put them on the same row, side by side comparison. You have to, yeah, that's why this article is very interesting. I've been looking at the internet to see something that you can easily understand, well documented. Right, this is a very powerful set of functions, the lag and the lead. Businesses use this a lot. Comparative analysis, year over year analysis, right, month over month, quarter over quarter analysis. This is very important. Right. Now, if you're on this row, that's the last row. What was the previous sale value? Is this one. The lag function pulls that. See, that's it right there. So the last column you see right here is the outcome of the lag function. Right. Now it's just to code it. Right. So this is how you're going to code that. I won't call those values like the way they are. Let's just put let's ignore the sale ID. Let's just put the sale name. And let's see. Yeah, maybe we can. Yeah, we can put it. Let's just put everything. Let's do the ID, comma. Let's do the seller name right there. Right. And let's do this right here. The sale value, right? Based on the analysis we are doing, I want us to call this current sale value. Let's modify this to current. So in our analysis, this is the current sale value. So we can start understanding the difference between current and previous. Previous will be fetched by the lag function. It goes backwards and fetch the value. So this is the reference point. This is our position. We are calling this positional functions, positional window functions. So this is going to be our reference, the current sale value. What will be the previous? We can even investigate what will be the next. If this is the current, what will be the next? What will be the previous? That's the lag and the lead function. So let's begin with the previous. So given this current, what is our previous? Let me just run this. See that? So take note, this is what we have. Now we're going to use the lag function to investigate the previous. And if you want to investigate the previous, you have to base it on a certain column. If you go back to the syntax for the lag function, it has this, which is mandatory expression. If you're dealing with a column, that's going to table, sorry, that's going to be a column. So that will be the sale value. We are accessing the sale value. We want to go previous on the sale value. This is a current sale value, right? We want to investigate the previous. And of course, this is a window function. You must put the over clause. If I stop right here and run it, I get an error. I'm dealing with a window function. Lag is a window function. All window functions need the over clause. This is very important. I'm doing this gradually so that you see it. When you encounter those errors, you have to know what it means and then how to fix them. So I've added the over clause. All window functions need the over clause. This is very important. All of these window functions need the over clause. The over clause defines the window. Right? If I execute this, it fails. Why? Because I'm dealing with a lag function which mandatorily needs the order by. Your lag function needs the order by, just like every other function we study on the ranking window function category. All of these functions, they need the over clause. Remember that we need to know our current and then we go one step backwards to pull the previous. So there must be an established structure, well sorted. So that's why we're going to implement the order by right here. And we are ordering on what? We go back to this table. So it depends on the analysis you're doing so that you can nicely build the order by. In this analysis, we are evaluating the sale value. This is the column we are evaluating. So let's sort on this so that if we are on this row, the previous value for sale will be this one. If you're on this row, the previous value for sale will be this one. If you're on the first one, there's no previous, that lag function should return null. So we have to make sure that this column is properly sorted inside our window. So I'm going to go in the window and I do order by the sale value. Just basically copy this right here and put it right here. Right. You can add this to make it descriptive. If you remove this, the system understands that ascending is the default sort option. See that? Yeah, but you can still go ahead and add it. Right. So if I stop right here and execute, I've provided everything that the lag function needs at minimum to do its job. So we are assessing since we're using lag investigates the previous value on a given column. We want to look at the previous value on the sale value column. This is the current. Based on analysis, we've aliased this as current sale value. We want to go backwards and look at the previous sale value. That's why we're using the lag function. We express the column. This is different from these ranking functions where they don't take any column or expression. These positional or value functions, they take, you see, they are supposed to know the column on which they're going, previous or next on. This is very important. If you remove this, you get an error. Lag functions are not built like that. Ranking functions don't need any expression or column. See, this is very important. As you're doing this, you're seeing the difference. So you must state the column on which you're going previous on next on. And of course, this is a window function. That's why we need the over clause. We need to sort so that we know exactly what is defined to be the previous and what will be defined to be the next. Since we're using lag function, our interest is the previous. So let me execute this so that you see a new column has been built or generated. We can go ahead and alias this so that you understand it as this is what we call this current sale value. We're going to call this previous sale value. In any business question where you're asked to pull previous values, always think about the lag function. That's the goal of the lag function. It goes back on a defined window, properly sorted, and pulls the previous value, given the metrics you're tracking. So our key metrics is the sale value. So if we zoom into a particular column, we are looking at the sale value. On this sale value of this particular row, what was the previous sale value? Null, missing. If we go to the second row, giving this as the current sale value, what was the previous? It is this. That's why the function lag returns this. You see, I can compare the current to the previous on the same line. I don't need to do this to this. This is very important because in the next examples I'm going to show you, we're going to see calculations where you take a certain current, do some divisions on the previous, and then you multiply by 100. That's what you do with the year-over-year calculation. So extracting them and putting them on separate columns is very important. If you're comparing, this is your current, this is your previous, or this is your current, this is your next, on the same column, it doesn't make any sense. But if you put them on different columns, you can compare them side by side like this. And you can do further calculations on these columns. So this extraction is very important, right? You have to understand how this is built, right? You have to be able to visualize this process and understand it. So in an interview, you can explain. Right, please take note. This is very important. This is the lag function. It is going one row backwards to pull a certain value from the previous row. And this helps to do current versus previous analysis. This is very, very important. In fact, let me document that right here. What we are trying to do here is a current versus previous analysis. Right, current, have this in mind, current versus previous analysis. So you must set what your current is. Of course, you must, it's available in this case. We are using the sale value. So for each given row on the sale value, which we now call the current value, is this. And then based on that, we are tracking what is the previous given that current. This is a current versus previous analysis. And that's the power of a lag function, the ability to go one step backwards and fetch the previous value. So you have to look at it from a row by row perspective. First thing, the output has been sorted. We have this, this. Take note, if I distort this and I put descending, you're going to have a completely different result. If I run this, see what happens. See, now I'm looking at my window sorted in what descending order, the largest sale value to the smallest. See, and then giving this analysis on this row, what was the previous sale value? Unknown, null. On this row, what is the previous sale value? That's what the lag function is investigating, the previous value. So given this row, this is a previous value. That's why it takes it and put it right here. And you have to understand the movement of this arrow. On this given row, there's no previous. That's why the lag function returns null. On this given row, the row for Alice, this was her sale value she recorded for the day. What was the previous? That's what Steph did. That's why we have to put the previous, that's Steph's value, and put it next to Alice's value. you can see that current previous comparison. On this is milli or milli, and you see this is the current. What was the previous? The lag function goes backward this and puts this value. Now somebody can ask me a very brilliant question. Why is that the lag function is only going one step backwards? And that's where that parameter comes in, that optional parameter, this one, the offset. This parameter called offset controls how many steps backward can the lag function go. Without the offset, the default is 1. That's why I have not used the offset. See, I've used just the column. Without the offset, the lag function can only go one step backwards to fetch the previous. This is very important. See, if I modify this, let me do a next analysis right here and tell the system, hey, anyway, I'll come back to that. I want you guys to understand this gradually. I'm going to come back. But if you have that question in mind, then that's the answer. You can control that. Right now, the lag function is only going one step backwards. For each row, each current row, the previous is not known. That's why we have a null right here. Now, can the system be arranged such that we can put a value if there's a null? That's the third parameter, and that's still optional. This default value is the value the project manager can give you and say, instead of giving me null, put 0. The problem with null is that when you present a report involving nulls, report users don't know it. Null is an analytical statement. It's a database construct. If you're not in the database mindset, you'll not be able to interpret null. You think null is a value. So usually when you build reports for companies, managers will always want you to remove null and put something different, either a blank or 0 in this case. What was the previous sale value? It was 0 instead of putting null. So that can be controlled by this parameter right here. Any value set in this spot, the system, instead of giving you null, it will give you that value. So technically, I've explained the 3 expressions on the lag function. The mandatory one is this one. The 2 optional ones are this. So how many steps backwards can the lag function go to fetch the previous? You can control that behavior using what we call the offset argument or the offset parameter. If we land on a missing, instead of returning null, can you specify any value based on the business? Yes, that's the default value right there. Right. So please stop me when you have a question. Let me see if I can push us one step forward. I believe we should be able to understand this, especially this demonstration right here. Right. Controlling the logic of the lag function. Please, lag. When I started studying this, I was always confused. Lag and lead. And when you watch students in interviews, they confuse the two. Lag goes backwards. Lead goes forward. So lag is always tied to what? The previous analysis. Previous. Right, that word previous should indicate you're using the lag function. How do we fetch previous sale value? Given that this is a current, how do we fetch the previous? Is a lag function. Right, this is very, very important. Let me see if I can extend this further. So let's see. So again, that's this concept right there. And now I think right here we switch to the lead. So what we did previously, this example is the lag function. And I want you to remember that when it comes to the lag function, we are fetching the previous. This word is very important. You're fetching the previous value. Right? This is very important. Let me run this again so you see. Given this is a current row, what was the previous sale value? Is null. It's not known. This is our starting point in the window. Remember, we've sorted the window. This is our starting point. Let me switch this back to this ascending. Right, let me run this again. So given this window, this is our starting point right here. So there is no previous. That's why the lack function, which is built to fetch previous value, is returning null. Now, given this row, what is our previous value, previous sale value? This is it. That's why the lack function returns this. It goes backwards and fetches this and returns it. Given this row, what is our previous sale value? This is it. It goes backward, fetch that and put it right here. And that's why we say we are doing what? Current versus previous analysis. Each time you see this kind of stuff in any business scenario, always remember that you will need the lack function to do that. This is very important. Let me save this before I lose this information. This is lack versus lead function. These are window function. Right. I don't want you guys to miss out on this. This function has very powerful analytical potential. Right. If you're satisfied with the lead, the lack, let's jump onto the lead. I'm just going to copy this heading and we're going to build that same scenario. I'm going to switch. So for the lead, from the name, it gives you a clue, lead. You're fetching the next value. So remember, our reference position is the current. Right. So for the lead, you're fetching the next value. So basically, you're doing a current versus next analysis. Current versus next analysis. This right here, this is supposed to. This is right. So this is very important. Now let's go back to this analysis. Let's build this again. I'm going to copy this and just dismiss. It's just a change of the function. Right. Once you change this, the same, for the benefit of those who just joined, let me just dismiss this and let's build this all over again. Right, so that you can see how we came up with the right. So this is a simple table we have. I begin with simple tables so that you don't get confused by the complexity of the data. You focus on the concept rather than trying to figure out the data. The next, we're going to take you now to a big database and we'll demonstrate this issue. See? All right, so we're dealing with a very simple table so that you focus on the function itself, the behavior of the function, not the complexity of the data. See? So we're going to be treating this as our current sale value. That's it right there. So given that we are right here, this is a row. What is the next sale value? The previous sale value is not known. That's why we get null. But if you're using the lead function, you're searching the next. So if you're on this, the next is the one below this one. So if you take this and compare it to this on the same row. So if we switch this to lead function, we'll be getting this comparison to this on the same row. And if you find yourself on this row, this is the current. What is the next? Is this going to be this one? So it's going to compare this to this on the same row. If you find yourself on this row, this is the current. What is the next? So the lead function will return null for this one because we don't know the next. If you are using the lead function, the lack function, a null will be returned for this one. We know the current, we don't know the previous. If you are using the lead function, this is the current. What is the next? The next is null. Right. And how do you build that? That's the benefit of those who came late. It's lead. You're looking for the next. This is very important. Right. The lead investigates the next value in a given window. And so you must always tie this function to a column. It must know the reference. Right. We are doing it based on this right here, which we call with alias it to be current sale value. So based on our current, what is a lead? And this is a window function. All window functions must carry this keyword over, and the over clause defines the window. A window function is a set of functions that acts on a window. The window window is defined by the over clause. A window is simply the set of data on which the function will act, right? And it is mandatory to sort that window so that we know the position above or below. Above the current, we are going to the previous. Below the current, we are going next. This is the current. Above this current is the previous. If this is a current, below this current is the lead, the next. So you have to sort that column properly. That's why if I stop right here and run this function, let me first of all demonstrate this. In fact, let me go all the way to this. I show you things you cannot do. You cannot call lead like that. You must specify a column to use as a reference in fetching previous or next. This is very important. In this analysis, we are using this as the reference. First, run this again. This is a window function. All window functions need what? The over clause to define the window. So if you run this, you have an error. It identifies that this is a window function. It must use an over clause. You've not specified the over clause. Over this. This is still not enough because you have to sort the window. These are positional function. The position is very important. So you have to sort this window. So that's why we introduce the order by. In this analysis, we are mainly focused on the sale value, and you can choose to make it ascending or descending. But in most businesses, the sorting will be done maybe on a date and time column, right? Especially in transactional like sales, online purchases, and stuff like that. All right, you see that? So now you have to step in and understand. First, let's give a name to this column. Since we are using a lead function, this will be the next sale value. So we are comparing what? Current to next. This is next sale value. Right. First thing, let's put that column name right there, well descriptive. Now let's zoom in and try to make sense of these values. How are these values being generated? If I take you to that online document on the segment where they use the arrows, it will be easy. If this is the current row, this is your current sale value. What is the next? The lead function goes forward, lead of this value, and paste it right here. So this is your current next comparison. Current sale value compared to next sale value. That's a comparison right there on the same row. If we are now on this row for a list transaction, this is the current sale value. What is the next sale value given this as the current? You move forward, that's a lead function, picks up this value and puts it right there. That's the comparison. If now you're on this my list transaction right here, this is the current sale value. Now what is the next? That's the lead function. Investigates is not provided. The data does not extend to go into the next. And that's why it returns null right here. So that arrow helps to clarify. You have to read this online article over and over to understand this. Are we okay? So that's it. Very, very important. And you can now spice this up by doing partition or using the lag and lead to compare values. This is another very important one right here. We have this table. So let's switch to annual sale. Right, I'm just going to copy this using the lag and lead to compare values. And we're going to be using the annual sale. So I'm taking you to a new table. All right. Once you execute that window function lab database, you have all the tables provided. If you just copy this name right here, and that's a table, you do a select star from that table, you have the same image. You have the same content you see on that tutorial. Select star from this. You have the same right here. Annual sale run. Of course, annual this is a simple table. Why is this taking too long to execute? So annual sale for each year, we are showing you the sale value. Guess what? A business can tell you, create a report which will compare the sales in 2016 to the sales in 2015. In that case, this is the current. What is the previous is this one. And you're comparing them on the same row. I don't want you to go vertical, this compared to this. No, stay on the same row, horizontal. So you use, since you're going backwards, you're going to use the lag function to show this as the current, fetch this value and put it next to this as the previous. See, compare values. We are comparing the total sale for the current year. If you're right here in 2016, that will be the current, to the previous year, which will be what, 2015. If you're starting your analysis at this point, there is no previous. So the lag function will return null. Let's do this together. Let's first of all understand this annual sale table. It's a very simple table. I'm exposing you guys to simple tables so that we focus on the concept, not the complexity of the data. This is very simple data. Each year is listed and the total sale is provided. And the equation is very simple. As you can see, the table contains a sale amount by year. So if we use the lag function and the lead, we can compare annual sale amounts across the years. So I will take you to this side and let's do our own copy. Right? We know exactly what we want to compare. Let's begin with the lead. We'll do both. Let's begin with do lag. So let me just call up some columns instead of having asterisk. I'm just going to call up some columns on this. Let's first of all run this. There's just two columns. So we're going to show each year. So my first column to call will be year. And you have to understand that year is a reserved word in SQL. That's why it's highlighted like this. It's a function called year. So it's thinking that we want to use year as in the context of a function, but in this case, we want to use it as a column. Right. Sometimes it could be problematic, but if it's not a problem, you can go ahead. If you are not comfortable with this, you can suppress it like that. Now the system understands that year in this context is being used as a column. You see, when I put my cursor on it, it identifies that as a column, right? And I can go to the next one. I want to get this total sale right here, right? And then I'm going to be fetching, I can just call this, you can see use that current terminology, right? This is a total sale. We can alias this as current underscore sale. Then now to fetch the previous on any given year, you have to understand that the sorting needs to be on point. You have to sort correctly. So if I initiate this process with the lag function, that's to look for the previous, I will do all those errors that you see. Lag function needs a column. There must be an expression. If you go to the syntax of the lag function, it needs an expression. And since you're working with a table, an expression in this case will not be a column. So what column are you going to put right here? What are you testing? The metrics you're testing is what? Total sale. So we're going to put total sale right here. This is very important. You see, I start by running this. I want to show you all the possible errors so you know how to fix them. Right. This function needs an expression. And since you're working on the table annual sale, we need to specify a column right there. So we're going to be using this total sale. Right. It's not enough. I execute. Lag is a window function. All window functions carry the over clause. That's their symbol. That's their, that's what identifies them. Right. This is very important. So we need an over clause right here. If not, we get an error. Right. And if I stop right here, you see this query looks clean. If I run it, I still get an error because the lag function is kind of a positional function. It is fetching things. It has to be applied to a sorted window. Right. And what is the key thing to sort right here? You have to sort based on the year. We don't want to mix things. You see, this function will confuse if you have this and then it goes and fetches maybe that of 2015. Right. So you have to sort them correctly. Right. So we're going to sort by year and just copy this and put right here. And you can add, is it ascending or descending? You want to do it ascending so that we do 2015, 16, just like that. So this right here, I'm missing my order by. This should be order by that. See that? And now if I execute this, I think we've provided everything for that lag function to do its job. Right, let's go ahead and provide an alias for that so that we can understand exactly what we're looking. This right here is what? Previous. This is no longer current, this is previous. So the lag function is going backwards to fetch the previous total sale. And when I run this, if I'm looking at this, I'm looking at 2015 sales. This is a current sale, current total sale for 2015. What is the previous? This data set does not give us the previous. So the lag function sees nothing, and that's why it returns null. Previous should have been 2014, but 2014 is not provided in this data set. That's why the lag function goes backwards, previous, and returns null because it doesn't find the previous year. If you're on this row, these are positional functions. You must always have a reference point. So if you are right here, you're looking at the current total sale for 2015. What is the previous total sale for 2015? It's not documented. That's why the lag function returns null. If you go to the second row, this right here is the total current sale for 2016. This is it right here. This column is reporting the previous total sale, and for this particular value, this will be the one, the previous for 2016, which is what? 2015. So you see this value is taken 2015 and it's placed right here. The function consider this to be the current if you want 2015. The previous, that's the work of the lag function. Previous goes backwards, fetch this and put it right here. Now you have a side-by-side comparison. You're comparing the total sales for 2015, which is this value, to the total sales for 2015, which is this one. And sometimes you can be asked to compute another column called difference. What's the sales difference between the 2 years? It's just going to be this minus this. If it's positive, you had an increase in sales compared to the previous year. If it's negative, your sales went down compared to the previous year. This is very powerful. Those who are in businesses, and they're already enjoying this. Right? Businesses like to do this kind of comparison. It could be a month-over-month comparison. It could be year-over-year. You want to know the health of your business. You want to track things, and are you improving or are you depreciating? Are you regressing? You have to. This is very important, right? So this is it right here. Any question on this? I keep executing this and I forget to provide you with the copy. Anyway, let me just go ahead and build that for the, let's build that for the lead, sorry. The lead goes forward and fetches the next. See, if you want, we can actually adjust this out. Anyway, let me just go ahead and then we can do the adjustment later on. So again, the repetitions are right here. This function takes an expression which is mandatory. See, you cannot just call lag without giving an expression. That's lag. We talked about lead right here. So that will be the nature of the syntax. You cannot talk about this function without passing an expression. Since if you're working on a column, if you're on a table, that will be a column. So same thing. Our reference is total sale. We're going to put it right there. Right, this, you see, it looks good right here. No red indications of an error. But if you execute, you get an error. Simple these are window functions. All window functions must carry an over clause. This is non-negotiable. Right, the code looks clean, but then if you run this, you get an error. Right, these lack and lead functions, they need an order by, just like the ranking functions we saw. So we're going to maintain the same structure. We're going to order by the year. Now, if you run this, we finally hit our target. Now, to just make things descriptive, this is what? This is the next total sale. All right, so you see this analysis here. We have current, previous, and next. I hope you can see exactly how interesting this could be from a business perspective. Right. There's an example we're going to see on bonus. Most companies have already disclosed the bonus they're going to target next year for their employees. Instead, they target at the beginning of the fiscal year. Right. So something that's already been set for the future, you can use a lead function. It kind of goes into the future and finds that value. So every company has already set their bonus for the next year, the target. Right. So you can use the lead function to find that. There's an example we're going to look at. So let's run this. And now this is what we have. Now, from a visual perspective, I'll rather present this information like this. Right. Let our current be in the middle. And then let's sandwich that current with previous and next. This is the best way to present this. Right. This is our current. So now look at it from a row perspective. On this row, if this is a current, what came before this function? That's its job. Nothing. That's 2015. There's no 2014 data. So previous, given this current on this year, is null. Nothing. See that? But then now if you look at the next, the lead, given 2015, the next year is 2016. So given this value right here, what was the next? Is this one. That's why on the next total, we see it right there. This is a comparison of what? The current total sale for 2015 to the next total sale after 2015. The next year is for 2016. That's why it's plucking the sale value, total sale for 2015, and it's putting it next to, 2016, and it's putting next to 2015. Right? You have to sit back and go over this. Right? The good thing is that the article is right here. I will share this again. So you have to take great time and go over the article and study it. You have access to all the databases that are referenced in that article, all the tables. So that's basically what they did right here. Right, and I did mention something about the difference in this kind of different analysis where you have the lag. Let me extract this. So let's dismiss the lead that's going into the future. Let's just only focus on the lag. So given your current, will fetch the previous, and then let's see the delta. Some people call this the delta, the difference. And the businesses always do that. What is the delta? Change in the sales for this year to the sales of last year. So delta change. I just want to give you the business terminologies on this. Difference, right? This is very important. Right? And in this case now we can switch this. Let's begin with what we know, that's the current. And then we go fetch the previous. And then now we can look at what change was the delta. See this? This is the current. We don't know the previous. This is for 2015. There's no previous. The lag function returns null. Right. And what change? See, it's going to be this minus this. That's a delta. Difference. Businesses do this a lot. Right. So if you want to do that calculation, you have to take the current, which is this one right here, minus the previous, which is what? The previous is the outcome of the lag function, the investigation of the lag function. This one, we are copying just the logic. I hope by now you understand that you cannot copy the alias. You cannot build a column in the same select and proceed to use it in the same select. Somebody has once challenged me, why is this is not possible? Yeah, SQL does not operate like that. You have to understand that on the select, once the database engine hits the select clause, everything right here is processed simultaneously. So you cannot be creating something and you're calling it another in the same execution. See that? That's why I keep going back to the logic. Right. This is very, very important. Go back to the logic and this. So this is how you get the delta, the difference between the current year total sale and the previous year total sale. This is what business is called, the difference, the delta, the change. And when you go to Power BI, you build KPIs, you see, some interesting analysis, right? This is it. Whenever that difference is positive, there was a growth, there was an increase, there was benefit. You see, there was, more sales were made compared to the previous year. Progress. If that quantity is negative, there was a regression, right? And if you build a dashboard, you can use now KPIs like red, green, to indicate this stuff. This is very, very important. Let me see if I can pull up the KPIs, key performance indicator, KPI dashboard. Or let's just put the sales KPI dashboard. You're going to build this in Power BI. Most CEOs, when they get to the office in the morning, they just check their KPIs on their Power BI dashboard. They want to see green stuff. When they see red, that's not good. Right. These are what we call KPIs. See this? When it's green, it's fine. When it's yellow, you have to adjust something. When it's red, it's really bad. So you're going to build interesting stuff like this in Power BI. Okay, let's go back to this. So that difference right here, take the current, which is this we have, minus the previous, which is what the lag function does. This is the difference. Some people call it the delta. This is it. And you have to understand that any calculation that involves null will always be null. This is something that every data analyst using SQL should know. Any calculation involving null will be null. 2 multiplied by null will be null. 2 plus null will be null. Whatever thing null will be null. Right? Take your name, concat it with null. The entire expression breaks down to null. You have to understand. You have to know this. Null messes up everything and pushes it to null. Null is really, really powerful. It is not a number, it's a placeholder. So it just destroys your calculation, whatever logic you're trying to put in place. Right? This minus this is, see, just copy just this and test it. When you're studying, you can feel free to do this so that you can have a better understanding of the process. Isolate a particular row. What are we doing? We're taking the current value minus the previous. That's basically what we're doing, and run this. It goes down to null. Any calculation that involves null in any spot will go back to null. You have to know this. Right? This was really frustrating an interview. Somebody once asked me this, I could not understand. Could not answer in an interview. They asked me, so you've been working for 5 years. My experience at that time was 5 years. And you've never known that anything involving null is null. It's really shocking. It's really frustrating, Yeah, but these are key things to know. Any null features in your calculation, it goes down to null. This is very important, right? So this minus null is null. If you think now this minus this, you can isolate that calculation and test it out yourself. right? It's gonna give you that this minus this. This is the current. This is the sale for 2015. No, sale for 2016. That's the current. We are now in 2016. What was the previous? The previous is the sale for 2015. This one. That's why we say this minus this. You see that when you put them on separate columns, it's easy to take one column minus the other. But when they stay on the same column, you keep doing this minus this. There's no way you can code that in SQL. This minus this. See that? You have to understand why we are extracting this and putting them on separate columns so we can do this nice simple calculation. One column minus the other to get the difference, the delta, or the change. You cannot be doing this minus this and you code it. When you go to the next one, you start doing this minus this. When you go to this one, you start doing this minus this. When you right here, you start doing this minus this. You have to spread these things out on a separate column. And that's why T-SQL provides this lag function, the lead function, right? Spread these things out onto separate columns. Right? You can build a calculation involving columns. Don't stay in one column when you're trying to control this value right here multiplied by this one, or this one right here divided by this one. See, that's going to mess up a lot of things. When you spread them across different columns, you've isolated the columns. You can now take this minus this. See, those are two different columns, and we're getting a nice result right there. Right. So that right there, there's a delta or there's a difference. I think that's it for this one. I'm just keeping the explanations. You create time to read them. Right. And then this one highlights the concept of offset when you bring in that second parameter. See, this is a very interesting example. Bonus. This is what I was referring to. This is a bonus spread across different quota. All right, let's address this one. All right, and this exercise will highlight the importance of knowing how to use that offset parameter for either the lead or the lag function. So the key focus in this segment will be this right here. We've used this only. So all the examples we've built, they've just involved this. Right. We now want to see this. Right. Let me just spread them out and remove that confusion with the square bracket. And usually when you put this, you don't put this, the system assumes the default. Null in this case is the default. So the default for offset is 1. You see this offset parameter right here. I'm just going to document the default. It's 1. When you read that article, you understand it. The default for offset, I'm just going to put offset. The default is 1. Default, the default for default is null. It's null. That's why when the lag function goes backwards, it doesn't see a value provided. It defaults to that null. But you can control that process. So in this example, we're going to be looking at a scenario where we are having this picture. A picture involving just the expression or the column and an offset. All right, let's go back and address this. So in this example, we are looking at this table as an employee. Let's do a select star from the employee. Let's discuss about it and understand it before we can analyze. Now you understand the power of exploration. You cannot analyze a table without exploring it. You have to first of all explore the table you're dealing with before you can proceed to analyze. Right, so this, I don't know why my system is really slow. These are very simple tables, but see, when you execute something and it's busy right here, see this is red, and then you see executing query. See, it's still processing, but that's a very small table. See, there's a table right here. Right, maybe this laptop has been working since last night. It's always good to shut down your laptop. Right, this is something that's very common to most IT. Sometimes it starts performing slow, it's been on for, or maybe you have to always run your restarts, always reboot your laptop, restart, shut it down, run those updates. It's very important. See, this is a performance issue right here. Very simple table is taking forever to run and generate the result. And you always know from this. And if you want to cancel this query, just click on this red button. Right, and you see it switches to what? Canceling query. And sometimes it could be really frustrating. You could be forced now to shut down Management Studio completely. I think that's what I'm going to do. Right. So before I shut it down, make sure you save that script. I'm going to close this. And you can get the sound. Sometimes you can just go to the taskbar. I click on that and close the window. This is very frustrating. So I'm just going to shut down Management Studio. So while it's shutting down, I will use this to explain. So we're dealing with the employee table. You have access to that. This is just one particular employee. You see, it's the same employee. Why? Because same employee ID throughout. In a company, no two employees have the same employee ID. So this tells you you're looking at the same employee. So we are showing the year, each year, and the quota. Each year has 4 quota. That's why if you start on 2017, you see 4 rows before you move to the next year. So each year has 4 quota. See that? So now this is the bonus example I was talking about. So in 2017, first quarter of 2017, this employee had $100 for bonus. I'm just going to put the dollar amount as dollar. In the second quarter, that's they worked in 2017, January, February, and March. The company gave them a bonus of $100. Now the following April, May, and June, that's second quarter of the same year, they got a bonus of $250. I'm now trying to explain this data set so you understand it. The complexity is increasing, but it's simple to understand. All right, third quarter of the same year, that same employee, you see, the bonus drop, maybe they underperform or something. You see, the bonus drop to that. 2017, the last quarter, even worse, the bonus dropped to this. So this is the scenario for the 4 quarters of 2017 for that employee, and this is the bonus amount you see right here. 2018, same picture. You see the 4 quarters and you see the bonus amount reported. 2019, same picture. You see the 4 quarters and the bonus amounts reported. Right. Now, we want to do something very interesting. We want to use the lag function. For example, this is 2018. Right, this is 2018. I want you to compare the bonus of this employee in first quarter of 2018 to the bonus of the previous year of the same quarter. You don't want to see, if you don't add that offset value, you will, for example, take first quarter of 2018, the previous will be this. If you use the default, you just call the function without indicating that offset parameter. By default, the offset is 1. So if you're on this row, the lag function will go 1 step backward and pull this. You will be comparing first quarter to fourth quarter of the previous year. You don't want to do that. You want to keep the quarter, preserve the year and preserve the quarter. We should be comparing first quarter of 2018 to what? First quarter of 2017. That's the sensible comparison to do. Don't compare, if you don't put that offset value, by default, the lag function would consider this to be the current and the previous will be this. So you will be comparing first quarter of 2018 to fourth quarter of 2017. That's not the kind of comparison you want to do. You want to compare the bonuses in the right quarter of each year. See that? So the quota, the bonus amount for first quarter 2018 should be compared to the bonus amount for first quarter of 2017. That's why they are using the offset. Offset is the number of rows you're going to skip. An offset of 4. If I am on the first quarter for 2018, right here, I should be able to skip 1, 2, 3, 4, so that I compare this to this. That's the right comparison. So that when I call the lag function, it goes previous 4 rows backward. So that I compare first quarter to first quarter. You see, this is very important. If you're on this 2019, you're comparing fourth quarter of 2019 to what? Fourth quarter of 2018. So right here, 1, 2, 3, 4. That's the comparison. This is very, very important. Right. And that's where that offset, when you read this article close, that's where that offset parameter comes in. If you don't need to skip anything, you don't use the offset, the system assume it to be 1. But in this particular kind of analysis, you need to make use of the offset so that you want to stay in within the right quarter. Don't compare third quarter to fourth quarter. Right. In this kind of bonus comparison, you have to, but then depending on the business question, sometimes you can compare current quarter to previous quarter. In that case, the offset is defaulted to 1. You just have to kick it out. Right. So you have to understand. And in this case, the third parameter, which is what? The default is set to null. So, for example, if I want to compare the bonus amount for first quarter of 2017 to the previous year, to the previous quarter, there's no 2016 data. So the lag function will return null. If I want the lag function to return some other value, I will now put a comma right here after 4, and I put the offset, the default value to return. So when I skip all the way to 4 rows backwards, if I don't see any data that's available, instead of returning null, I return that value. Right. So that's how those 3 parameters come into place. So now you understand this is the testing column. This right here is how many rows you go backwards to fetch if you're using the lag function, or how many rows you go forward to fetch if you're using the lead function. And since we did not specify the third one, the default is null. See that? I really want you to understand. This table will give you a perfect explanation on that. So if the current bonus of this person is this, let's look at the next bonus. So this is what here is 2017. The next bonus of first quarter of 2018, you have to look through, skipping what? 4. Right, because this offset was set to 4. So I'm going to skip. This is the current. If I'm looking at the next, this is the current. I'll skip 1, 2, 3, 4. See, and then this is the value I'm going to look at. So going forward, this is the value you're going to see in front. So if you're in 2017, this person, first quarter of 2017, they had $80 in bonus. Function goes forward and skips 4 rows. If this is the current one, it's going to skip 1, 2, 3, 4. Status right there. You see, it returns this value on the lead 80. So first quarter of 2017, this person's bonus was $100. First quarter of the next year, that's 2018, that person's bonus was $80. And you can verify that for yourself. This is it. This is first quarter of 2018. That's it. That's for the lead function. For the lag function, you're going backwards. This is your current bonus, first quarter of 2017. There is no bonus for first quarter of 2016. That's going backwards. That's why this is null. There is no bonus amount for second quarter moving backwards to 2016. That's why this is null. Same thing. See? So there's no year before 2017. That's why all of these 4 quotas are null for previous. Meanwhile, for next, you're moving forward, the data is available. But in this previous, you're going backwards, the data is not available. The start is 2017. There's no previous to 2017. All right, this you have to understand. And that's the process right there demonstrated. And you also have to know how to use the partitioning. I think I've spent a lot of time on this. I'm going to skip this. And I want to take it to an interview question so we can solve. And this interview question is based on, we're going to do two. One, Uber. Now let's begin with the one that ties to this concept we just demonstrated. I'll take you to LinkedIn, and I've provided you the appropriate data sets we're going to use for this interview question. All right, these interview questions are actually trending on LinkedIn. Somebody posted them. There were 4 tied to this window function. I think my system is slow because of my internet connection. So let's take this interview question. I think we're going to understand much better on this lag and lead. I think my internet is slow. So right here, so these are 4 top companies: Uber, Google, Spotify, Wayfair. Now, so here's 4 real SQL window functions across these different companies. So I'm going to copy this. Right, and I want us to deal with the one that has to do with what we just studied, this one right here. Right, this is using the lag function to find a very popular concept in businesses, year-over-year growth. Right, so let's use this. I'm going to click on this and I'll share that with everyone. This link right here, I'm going to share this. They actually classify this interview question as hard. Right, but based on the lag and lead function we just studied, we should be able to address this. First thing, we need a database for Wayfair. So if you go to this is a Wayfair. Wayfair is a retail company in the US. You just take this and just type Wayfair in Google. It's an online retail store. They sell basically almost everything. That's the logo right there. It's a furniture. They sell every kind of possible stuff. Right. So sometimes it's good to do an exploration, understand what the data is all about. There's a company called Wayfair. It's online. You can buy household equipment and stuff like that. Almost everything. So that's the background information. I like providing background information on things. This is very important. When you join a company, read. Right? Don't just jump into data set and start explaining, start analyzing. Get the background information on. So that's what Wayfair. That's it's a company online shopping stuff. Now you understand that background information, right? So I did provide you with a Wayfair database script. Let's go ahead and open that script and execute. We need to have access to that database. So let's do this together. Open the script. So navigate to week 6 lab, open the Wayfair database script, and just simply click on execute. For those who've executed already, you're fine. If you've not done it yet, done so, just click on execute and make sure once it's executed, shut it down. I don't want you to have the script open once you've executed it. after execution, the script is basically now useless. It's just for documentation purpose. If in case you lose the script, you can go back. Right. So I'm going to close this. Right. And then you can always check by first of all refreshing, and then you check. Yeah, this thing is still really slow. Check and make sure you have a new database called Wayfair. While that is loading, I'll just come to the side. And the system gives you an example of a transaction, a user transaction table. This is what we can do on Management Studio as well. So we have it. This is me exploring the table to understand before I even go and read the question. Right. So we're going to be using the user transaction table. For those of you who have your stuff open, you see mine is still messing up. You can just do a select star from that user transaction table, and this is the output you get. It shows you the transaction ID. So when you purchase something on the Wayfair website, right, a transaction ID is generated. Right. Now, what products did you buy? Every product has a product ID. So on this particular transaction, this is a product that was bought. This is the amount. And then this is the date and time the transaction took place. So you log into that website, select some items, purchase it. Basic information is stored about that transaction. Transaction ID, the product that was purchased as a product ID, the amount that was spent, and the transaction date and time. This is very important. So having understood that data, this is really, okay, anyway. So having understood this, we can now target this part. Assume you're given a table containing information about Wayfair user transactions for different products. Write a query to calculate year-on-year growth. And if you click on this link, you're going to see the definition for year-on-year growth. We're going to come to that. Year-on-year growth for the total spend of each product, grouping the results by product ID. At this point, we really need to explore this definition on year-on-year growth. And if you go all the way to the bottom, you see right here, it's similar to the things we've been doing. Current, you see that keyword current, and then last year's, that's what previous. So it's basically current minus previous. We've done this calculation today. That's the difference, or the delta I was talking about. So this is available in the table. That's the current. Right? We have a column called current. This is what the lag function we investigate. Last year, it goes to the previous year and fetches. You see? So this is what the lag function investigates. This is previous. Last, same as previous. And then you divide by this and multiply by this. So the first thing you do is you have to extract all of this information into separate columns. Then you can now implement this calculation. With the exception of this is just a multiplication by a fixed factor. Right, so when you have a question like this, you have to first of all extract this separately. This right here, you need a window function. Last year's earnings is like previous, and the focus is on what? Years. So on this transaction data, on this transaction stuff, you have to go and focus on the year. Take note, we need to use the transaction date and extract the year from it. And if you read further, the output should include year. See that where do you get year? Based on the current data, you use the transaction date column to fetch year. Since my stuff is acting up, I can just maybe let me code it right here. This is not going to work because the year function is extracted differently. This system works on PostgreSQL. If I click on the solution right here, you see, not even on the solution right here, you see how they are trying to extract year. In T-SQL, you just put year function. In parentheses, you put transaction date, and that will do the extraction to get year. And then we also show the product ID. It's one of the quantities requested. Show the year. That's use the year function on transaction date. That's how you extract the year. show the product ID. Product ID is available. This is it right here. Show the current year's spend. It is basically this one, right? That's the current of the years you've extracted. That's what they call the current. So what you're going to investigate now will be the previous, this one. And that's what we use the lag function. Remember, previous means you're going backwards. You use the lag function to fetch this column. So once you have your current and your previous, year-on-year growth can be calculated. And that's the formula in that link. Let me see if I can do this. So the year-on-year will be the current year spend, this first column right here, which is this value, current year spend, divide by the previous year spend, which is what you fetch using the lag function. And then you multiply this by 100 to transform it into percentage, because this is going to give you decimal and you can express as a percent, you see, percentage. And this is what we call the year over year. And since we extract as a percentage, you can call it year over year percent. So when a company gives you a formula like this, you have to first of all extract all the necessary parts of the formula. This is available. This is the spend, current year spend. This can be extracted using the lag function. That's previous. You're going one step backwards. Previous year spend. And that's it. That's the calculation you're going to use. See, yeah, my system is still acting up. I'm just going to shut this down. My system is still, yeah, I needed to refresh my laptop before the session. You know what, guys, we're just going to end here, right? I'll give you time to study this article we covered today on this new function here, the lag and the lead. And first thing on the class of Saturday, I will go over this example, and then we're going to touch base on the key questions on that project. Now, this thing is acting up. Yeah, I have to restart my computer. Oh, just a moment. Let me do this. File open. Okay, week 6 lab case statement. Yeah, before we go, I want us to just touch base on this. So I want to first give you time to look at the lag and lead function. Then on Saturday, first thing, we're going to address more examples, and we'll talk about that interview question right there. So let's talk about this before we leave for today. Let's address this lab questions you've been working on. So this runs on AdventureWorks. I did provide this query right here, and the goal was for you to examine the query below. And the purpose of the script is to show count of each person type, and they want to show all 6. right? However, the script has 3 errors. So this script right here has 3 errors. Right here. There are 3 errors in the script. That's why the script cannot execute. So you get an error. Right. Did anyone identify the errors in the script? So first thing, let's go over the script and try to understand what it's doing. So we want to count, we want to show a count of each person type. Right. And so if you see what's going on right here, this is a case statement. Let me first of all extract this part only. Right, and show you this, and just do a select star. Right. So person type is actually abbreviated EM, or you can just put distinct person type right here. And this is actually coming from the person table. If I stop right here and I just do select distinct from person type from that table, I should get that information. Select distinct person type. It should be a person type on this. This is it. So this is a 6 they're talking about. But then if you notice, they use the case statement to show the full meaning of the person type. This concept was obtained from the data dictionary. So IN means this is an individual customer. See that? And then EM means that's an employee. SP means that's a salesperson. SC means it's a store contact. VC, vendor contact. JC, general contact. So that's what they're doing right here. They're using the case statement to make that column descriptive. So the first thing you want to do is, hey, based on the knowledge of your case statement, let's investigate if the case statement was written properly. So yes, every case statement begins with the case keyword. We put the when carries a condition. You see, when this is IN, then we get this. So far, everything looks good. All the different definitions, 6 of them have been properly defined. And then what do you do? At the end of a case statement, what do we do? There's an end keyword that's supposed to feature right here. If you go to this case statement syntax, we talked about this in the class. Every case statement must terminate with an N. And that's the first error you see in the script. This case statement right here does not terminate with any N. That's a serious error. So if you want to fix this, you must put an N right here. See that we're now making progress. That's the first error. Case statement missing keyword N. Now this is the data, this is the type, the column name which will be generated from this process. So that's the first error we'll fix. But take note, there were 3 errors. So first, missing keyword N on the case statement. If you see try to execute this, you still get another error. And it complains that the person type is invalid in the select list because it is not contained in either this or this. All right, this is very important. Now you go back to the select list. We see a counting process right here. We're counting the number of employees. This is a count process. It means that this column has been what? Aggregated. Meanwhile, this column right here is non-aggregated. So all of this is a definition of the column person type. So what do? Person type needs to go into a group by. So we are showing each distinct person type, and we are counting the number of employees. How many employees are individual employees? This EM, what's the meaning of EM? EM, that's employee, individual customer. See, how many? That's what we're doing in this. So we have to make sure that this right here goes into a group by. And this right here is an alias. If I copy this and put it in a group by, I'm wasting my time. That's an alias. See, you cannot put an alias in the group by. We addressed that concept last time. Right. But then we can use the original column. This is a person type. I will still keep this. The original column is person type. So if I put group by person type, the system is going to identify that because it is a column. Select this thing on person type. These are the values in person type. The definition has simply made them descriptive, but then it's still the person type column. So I can now put group by this column person type. So I'm showing you each of those person type categories, and we are talking about a count of employees. So if I put group by person type right here, and I proceed to execute this, now let's see if our case statement works. Now it works. All those errors that you're seeing right there, I just have to, something is wrong. It's not a syntax violation. I just have to go to edit and then refresh the IntelliSense. Refresh. But you see, that's not an, now this query is good. So we fixed two errors. First, missing N on the case statement. That's the first error. Right. So go back to your script and fix this. The first error was missing keyword, missing N keyword on the case statement. This is very, very important. Every case statement must terminate with the keyword N. So that was the first error. Now, what was the second error? The second error we're missing a group by. See, we had to put group by this. Why? Because if we look at the columns on the select list, there are two. This is just the description of the different person types. This case statement, the goal is to make them descriptive. We don't want to see IN, EN, SP. We want to see this instead. So this right here generates this column called person type. And then we are counting the number of employees in each of these person types listed. So this column is aggregated, then formatted. But then the key thing is the aggregation. So this is an aggregated column. This is a non-aggregated column. The non-aggregated column was going to the group by. So initially we're missing that. So missing a group by for person type. That's the second error for person type. So when we added group by, it fixed that. But take note, there were three errors. They said two of the errors, the script has three errors. Two of the errors will not allow the script to successfully execute. So these are the two errors that were preventing the script from executing. The group by, if you want to go back and deactivate them, let's deactivate this. And let's also remove this. We now go back to the error we had initially. No group by, no N on the case statement error. So those two errors were preventing this script from executing. It fails. Now there's one error which is not, it's an error, but it's not preventing the script from executing. And that error has to do with the number of rows returned. And for you to see this, you have to understand that if we did a distinct on person type, there are more categories that we are missing. there are supposed to be 6 person type categories. 1, 2, 3, 4, 5, 6. But the system is giving us 1, 2, 3, 4. See? So the third error is preventing us from seeing all the 6 categories. So 2 errors were blocking us from executing the script. Right? The other error is causing the script to show incorrect results. Instead of showing us all the 6 person types and their counts, we are getting only 4. So 2 are missing. And whenever you start dealing with missing data in your results, it ties to the type of join you're using. You have to understand that inner join restrict things because you're looking at the intersection, right? Only the intersection. So we have to switch this. That's what you're going to do. It's just a clue. When you're missing information on your analysis, go back and question if it's correct for you to use an inner join. If not, switch it to a left join or some other join type. See, now when we switch this to a left join, more data comes into the picture. We are now able to see the 6, which is what the question wanted. The question wanted to see each person type. They even tell you all 6. And these are all the 6 person types and their counts. See? So the reason why you're not seeing all the 6 is because right here, they did use an inner join, which was just showing the intersection between these 2 columns, these 2 tables, right? But then when you change it to, let's go back to an inner join, so you see we're not seeing the 6 person type, you're seeing only 4. 2 are missing, right? So those 2 happen to be outside the intersection. So see why? Because that's an inner join. See, but if you change this to a left join, you're not able to solve that problem, right? And now you can see all the 6 person types and their counts. So the 2 errors that were blocking the query from executing, these are them right here. And then the third error, it was a data reduction error. It's due to the inner join. So third error is more of data reduction due to inner join, right? So this is a data reduction. Instead of having 6, all 6 person types, we had 4. We're missing 2. That's data reduction. And the reason for this error is the inner join. So data reduction error, and this can be solved by just changing inner join to left join. So go back to that query and change inner join. That's what the query had. Change inner join to left join. So we're just going to the left side and we're showing everything from the left side, matching or non-matching. So change inner join to left join. And that's how you solve that particular aspect. All right, this was something I just wanted to challenge you on. Start knowing how to read somebody's script with errors and then troubleshoot and fix and resolve it and then execute. Any question on this? So please go back to your script. Make sure you have an N clause right here. And then you can also put an AS right here, but it's optional. I always tell you that AS is optional. Right? If you remove this, it's fine. But what is mandatory for a case statement, it must terminate with an N. Right? If you remove this, you get an error. Then second, we are missing the group by. And then the last one that was causing the data reduction is this. So these are the 3 things we're supposed to do to fix that query. Let me share this. Right. So please go ahead and fix that query. Let me paste this so that you can just add it to that script, fix the error, and then highlight the entire script and execute and watch it return. First, it runs. So the two errors that were blocking it have been fixed. Then it shows you 6 outcome instead of 4. Why? Because we've switched from the inner join to the left join. Okay, let's look at question 2. This is just something to do a count on how many products are sold by AdventureWorks. How many of these products are actively sold by AdventureWorks? For you to solve this question, you really need to observe the data dictionary. Right? You need to observe the data dictionary so that you get to understand some of those definitions. And that was the goal of that particular aspect of the question. To solve this question, you needed to use something that has to do with products. Products, yeah, you can go to the products table. So I'm on products, on table name. Let's just scroll down to product. This is in alphabetical order. If we use the products table for this question, we can then see all those definitions. So this is the product table. It begins on this side: product ID, name, product number, the make, flag, finished goods, color. So these definitions are very important. So this is the table you're going to use for this question, the product table, since you're talking about products and it is found in the production schema. So you just simply need select star from production dot product. So let me put it right here. Select star from production dot product. This is production dot product. This is it right here. Any column you don't understand on this table, for example, things that are coded like this 01 and stuff like that, finished goods 01, you have to go back to the data dictionary and read it to understand it. Right. Product line is arrow stands for that. So you're going to see in the table product line, you see those references and you're confused about them. Where's that product line? This product right here. If you scroll, yes, you see arrow M, right? You can go back to the data dictionary and check that. So let's go back to the first question. How many products are sold by AdventureWorks? How can you answer this question? It's just a count of the product ID. Each product has an ID. Now, if you want to choose a column to do the count on, go back to the columns. Let's check product ID. It says primary key for the product records. Primary key simply means it's a column on which the information on that column is unique. No two products would have the same product ID. So if you want to count the number of products, you count on the ID. And you're sure that no two products will be counted more than one. So you don't need to put distinct on the primary key. It's not necessary. The primary key is already distinct, it's unique. So to solve that question, you will simply just use your count function on the product key, on the product ID, sorry. So you just simply do count product ID. This will be the total number of products sold by this company. We are investigating that on the products table. 504 products. And it's the same thing you see on the 504 rows. When you run this, you see 504 rows. You see other people solve this question by putting an asterisk, count on asterisk. Right. Count on asterisk. Right. This is the same information you get, same you get right here. Right. So you have to understand the business process, consult that table, check the data dictionary to guide you on that. See, that's the A part. In B, how many of these products are actively sold by AdventureWorks? So actively sold, you have to understand, is there a difference? You can go back to the data dictionary and check actively sold. What is that all about? So on the products table, we've talked about product ID. Product ID with name of the product, straightforward. The product number, you can also count the number of products by counting on this number. Now let's look at this one, the make flag. 0 product is purchased, 1 product is manufactured in-house. Okay. Now finished goods flag. 0 means the product is not sellable. 1 means the product is sellable. So this is what you're supposed to use. So we're looking at products that are actively sold, sellable products. Right. So if you go to this table right here, if a product, and that's why I attached this column. If you look at this question right here, this finished good flag was attached so that you could get a clue. Finished good product. Product is not a sellable item. So if I do select star from this and I go to the product, to the finished goods product, all the products that have 0, right, those are products that cannot be sold. They're not sellable. Meanwhile, the products that have 1, they are the sellable ones. So what's the question right here? How many of these products are actively sold by AdventureWorks? These are sellable products, in other words. Actively sold products are sellable products, and that's where the finished goods flag is equal to 1. So we're simply going to go to this count we did right here, add a where clause. That's what we do for B. A, that was straightforward. We just do the count, everything. Now, how many of these, in the second part, how many of these are actively sold? These are the sellable, or right, you have to add a where clause. In this count, only focus on those where the finished good flag is equal to 1. Equal to 1. These are actively sold products, sellable products. What's the total number of products? Total number of products was 504. Of these 504 total products, only this number are sellable, 295. See, this is very important, and all of this information is coming from the, usually if there's no data dictionary, you have to ask questions. What do you mean by actively sold products? What do you mean by this? Right? If you just join a company and analyzing the database, you don't understand what do you mean by actively sold. The business will define this for you. They can then point you to exactly what I did on this column. 0 means that the product is not a sellable item, cannot be actively sold. 1 means that the product is sellable. This is an actively sold product. So in that next count, we have to introduce this condition to it. That's what B is all about. So the goal of this question was just to highlight the business concept. SQL is not done in isolation. It must tie with the business concept. You have to understand the business to solve SQL questions. Right. This is very important. And then see how many of these active products are made in-house versus purchase. You see this concept of in-house versus purchase. I think we saw that in some column right here. You look at the make flag. Let me copy this. Make flag says if a product has make flag of 0, the product is purchased. If the product has a make flag of 1, the product is manufactured in-house. Right. So this question is a continuation of this. So you've already seen the products that are actively sold. Right. So how many of these active products? These are the active products. How many of these are made in-house versus purchased? So you need to rely on this definition right here, right, to further break down that stuff. This right here. We're gonna make use of the make flag column. Right, when you have 0, the product is purchased. When you have 1, the product is manufactured in-house. So you have on the C, you have to take this right here and split that count into 2 groups, in-house and purchase. See this counting right here. Yes, we have to split it into two. And that's when you can use your case statement. See that? This is very important. So case, when the make flag is equal to 1, I'm going to replace this. I will come back to the counting, but I have to do some adjustment right here. I need to do case when this make flag is equal to 1. Then what can we do? Then this is a what? This is a purchased product. I can just call it purchased. Right. I have to separate this. That's the goal, right? You have to separate this. Else, I can just tell the system null. Else, give me a null. And then I end the process. I want to put this into two different columns. You see, this is a column for only purchased products. And then the next one will be a column for in-house products. So for in-house, it will be equal to 0. No, sorry, when this is equal to 0. Yes, when that is equal to 0, we have purchased. When that same, so I can stop right there. And I create another one, still using the case statement. Case when this time around, when make flag equal to 1. Case when make flag equal to 1, then this is what in-house. So I'm splitting this into two. I have to do an else null, and then I end the process. So these are two different columns. Let's see what we get. So you can see which of them is purchased, which of them is in-house. And then the last thing you do now is just to count. You see, we cannot just put the count product ID. Now we can now do the count. Right? I can now, after this split, I can now take my count function. Count will not count nulls. See, count will simply count. This is a purchase 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, and counts just like that. So I will take this logic now and put it inside a count function. Count this. We are counting that logic. Right. And again, we can still go ahead and call this. This is now, let's make the name of this column. It's a purchase products. Right. And then we do the same thing. We count this. I'm going to cut it off. Use the count function. Put it in this. And then we use that same alias. This is the in-house. Another name for those in-house is the manufactured. I'll just call this now manufactured. So this is a count process. Now we get numbers, actual numbers. If you sum up these two numbers, they get the original number we had. You can also add that this count right here. This is the original count. And then this is the outcome you get when you split. So originally, these are the total number of sellable products. I can just call this as sellable. Right. This is total sellable. And now you get it. See, if you add this plus this, it should give you this analysis. That's one way to check. So the total sellable product is this. Of that, how many of them are purchased and how many is manufactured? You can just try this by doing select, add this plus this, see what you get. 295. So this and this gives you this. Right. This question has to be understood. It's a continuation. Right. So we first of all did this. That's why we had a 295 sellable products. How many of these active products, active sellable products, are made in-house versus purchased? That's the split. So we use a case statement to come up with that split. And then we do the count. This is it. See that this is a split we've done. So we first of all use a case statement to identify, and then we use a count function to now count the cases. To count the outcome of the case statement, which identifies only the purchase. You see, flag, make flag equal to 0, that's a purchase item from the data dictionary. If the make flag is 0, that's a purchase item. If the make flag is 1, it's manufactured. So we had to use the case statement to spread it out like this. And then I'll proceed to use the count function to do the counting. You see the split, we created 2 columns out of that. Manufactured, purchased, and manufactured in-house. Then we now proceed to use the count function on that logic to now count it. See, this and this. Right. I want us to stop right here. We're going to continue this on Saturday. Right. I will share the script right here for the first 2. Anyway, let me just go ahead and share this one. This is the second part. This and this. B and A. Right, so this is A. So before we go, let me share this. This is A, and that this is B, and this is C. Right. Yeah, both time we're gonna stop right here. Perhaps come back to those interview questions. Right. I'll give you time to study the lag and lead function so we can practice first thing on Saturday. We can solve those interview questions first thing on Saturday. Okay, yeah, we're gonna end here for today. See you on Saturday.